We should be
Okay.
okay. All right.
Good. So okay. Okay, so then we can go over the eight problem right now. Okay. Wait, can you tell me what eight queens question you're talking about? 'Cause I'm not entirely, because I'm not entirely sure.
Yeah, there was I don't know, it's like pretty much all of the like beginning of the semester. You just had to go over eight queens with a 1D array and a 2D array. I'm more specifically asking for like 2D arrays using
Okay.
go-tos. If you want, I can just copy and paste the actual like code and I don't know, maybe you can explain it from there.
Yeah, it's like I don't think I have that resource right now. My bad.
1 second.
Yeah, we can do that afterwards for the hexadecimal one. But for now, we can like talk about the exam, how it's gonna be structured. Right now, the exam is gonna be like I'm not sure if we told you, but the exam is out of 160 points, right? The If you score anything above 100, it's still gonna be considered 100. So like essentially, the score from 0 to 100 is like the actual 100% score, and anything extra is like available for you to get a grab at. Yeah. Wait, is it? I mean,
Can I send files in here or no?
I'm not entirely sure.
I can, okay. I'm gonna send the actual code file itself and the
Or you can like,
portion of the
I'm
eight
not
queen.
sure if you're able to screenshot maybe. I think.
I sent both in the chat, see if you can open them.
Okay. Let me look at it. Oh, you mean the 1D array? Or
No, this is for the 2D. I'm pretty sure. Oh wait, you know what? This is the 1D array.
yeah.
It's okay. Just go over it anyways. I'm pretty sure 2D is very similar.
Okay, so So you want to go over the logic of it, right?
Yeah, please. Like pretty much like what each line does type of thing.
Okay, sure. Let's see. So code.
Actually, sorry, I just found my 2D version of it. If you can go over that instead,
Okay, sure.
I'll send it right now. It's very similar.
Did you see my screen?
Now we can, yeah.
So you have a 1D array, 8, initialize all of them to 0. You have your row and column. A row starts at 0, a column starts at 0. While true, row equals 8.
Sorry, I think my code is actually really bad now that I'm looking at it.
No, it's fine, don't worry. I'm sure it's been a while, so I'm trying to make sense
Yeah,
of it.
I made a few mistakes. I never noticed this.
Oh, if anything, I could look at mine then. Let me check it. I think it's the same one. Actually, no, it's different. We'll just go over to yours. So row equals 0, column equals 0. Up until our row, so like from bottom to top, we print Q. Minus C equals 1 plus 1.
Yeah, this code is like really bad. I don't know if you want to even use
No,
it as an example. Because I think I mixed up my row and C logic fully.
I did it.
Because it's supposed to print when it's C equals 8 and backtrack when it's R is equal 8. So I think I
Yeah,
fully like mixed up the two.
but when like when we reach to the end of the row, that's when we yeah. But if you want, we can go over the 1D array one. Yeah, sure. Yeah, sure, Louis. You can copy and paste yours.
Hey Louis, so I have the code from my when I took the 211. I could share my
Yeah,
screen and you could take a screenshot and just go over that.
sure, that works.
Okay, of
Thank you.
course. Can you see my screen? This is too big, huh? Wait a minute. Yep, this is too. This is okay. So this is the 2D array. This is the first part.
Okay.
And this is the other.
Wait, can you go back? Up, up. Okay.
This should be okay. See if this works. So this is the 2D array.
Yeah.
This is the 1D array. This is the first part
Wait, yeah. Can you go back up to the first one? Up, to the first bit?
here,
One more up.
here.
Yeah. Thank you.
Okay. Just take a screenshot and just go over the picture. Just use just your pen or something like that and go over that.
Yeah. Okay.
Did you get the whole thing?
Yeah, I got it.
Do you need the 1D array?
No, it's fine. I have that one.
Okay.
Oh wait. Yeah, you just copy and pasted it. Okay. Okay. Do you see my screen?
Yep.
Okay. So we have a board that's 8 by 8, the size of the chessboard. We initialize all of them to 1, and we have a row column starting at 0. You go to the next column, and once we reach the end of the column, meaning that we finish placing all the queens, we go to print, and then print that solution.
So once we reach the eighth column, that means that we already found a solution.
Yeah, so essentially, like, it's like this, right? We have like all the rows and columns, right? Once we're at like the last section, which is essentially the seventh column, right? Because remember it goes from 0 to 7, right? Once we're at 7, and then once we increment one more to get to yeah. So this is like column 7. Once we exit out and we're out of bounds, that's when we find a solution. When we place one of the queens somewhere around. That's what that logic means with the c equals plus plus c equals 8. We're just reaching out of bounds because we already found a solution. And essentially, we're going to the next column to put another queen, but there is no column because that's the end of the chessboard. Then we and then from there, once we place our what's it called? What's- That's not the case. If we make our row back to -1 is here. If we really
Lewis, if you're speaking, we can't hear you even though the green box illuminates. So I don't know.
Okay, sorry.
Okay, now I can hear you.
Okay, so if this isn't true, then we increment back to, we go all the way back to, our row goes all the way back to -1. We go to next row, row plus plus, so now we're here in row 0. We do the row test to see if any like conflicting queens happen. So let's see. I plus plus. Q R I equals 0, 1, go to next row. Okay, so if there's okay, okay. If for this for loop, we're checking if there's any other queens in these like other columns right here. If there is, then we go to the next row. So instead of staying here, let me draw a better grid.
Sorry, real quick. For the
Sorry.
for the initialization of the board where it says int q 8 by 8,
Yeah.
what is the equals 1? Like, what's the point of that?
You're basically equals to 1. You're basically initializing all them to 1. So like all of them equal to 1.
Okay, that makes sense.
Yeah.
And right afterwards for our next column where
Yeah.
r is equal to -1.
Let me answer that question. So basically, when you like initialize to the array and you just put 1, you initialize the row 0 and column 0 to 1 and everything else to 0.
Oh, hell, no, bad.
So you just do the row 0 and column 0 to 1, initialize that to 1, and everything else is 0. So you start from the first row, first column with the first queen, and after that you go to the next column and increase the column by 1, and it will not work out because afterwards you'll when you do the test, you'll have another queen on the first column, row 0, column 0. So you're gonna go to the next row and look, you're gonna go to the next row, and in the next row you're gonna look for other queen. Does that answer your question? When you,
Yeah, I think so.
okay. So when you just put 1, you initialize the row 0, column 0 with with your first queen. So is the equivalent of like putting your first queen in your row 0, column 0, and everything else like and rest of your board is empty right now. Okay?
Okay.
All right. If you have any more questions, please ask.
Okay, so what can be said, you're initializing the first row and first column to 1. That's what you said. And you're starting both at r equals 0. So our row right now is 0 and our column is 0. We increment the column. So since we already placed our queen in the first slot, we go to the next column, and we first check if c is equal to 8, which is not. So we skip this and go to row equals -1. So we're starting off with a row right here. It's basically -1. We go to next row, we increment row. So now our row is in row 0. Go back track. If a row eventually reaches like out of bounds, like if it reaches outside of 8, if it goes to 8, that means we haven't found a solution in any of these any of these rows. So then we'd have to backtrack to the previous column and like move the queen there to see if we find any new spot that could work for like later on. So in this for loop, right? So we went through here. Now we're on the row test. We want to see from here. From this we're basically placing our queen right here. Since we're in the first row, is first row, second column. Yeah, first row, second column. And then we check any like previous rows if they have any ones. And since right here doesn't have a one, we'd have to go to the next row. So instead, it'd be a row would be right here, and our queen would be right here. We check again. Right here, there is no queen right here, because this essentially checks like the row all previous rows. So like if our queen was right here, we just placed our queen right here, and we checked all the previous rows in this same row, and since right here there is a queen, there would be a conflict. So we'd go to the next row right here instead, and we just keep on going up until there is no conflict with the row. This one, this for loop right here. Oh, this one checks. This one checks. Let's see. This for loop checks if there's any diagonals. If there's any diagonal conflicts with the queens. So let's say right here, right, in this solution, our column is 1, and our row is also 1. So this is essentially where we place our queen. We go through this if for loop. So if our queen at row minus I, which first we start off with 1, so row minus I is 0, and then we check our column C minus I, which is I is 1, to be 0. So we're basically checking diagonally. So we go -1, -1. We subtract a row and we subtract the column up. So now we're checking this spot and see that there is a 1 right here that is conflicting. So we're not able to put this one right here. So we go to the next row. Same for this loop right here. It checks down diagonally. This is essentially the same thing. So if our row and our column was this one, our row was 1 and our column was column column was 1. This is checking if this R plus I and C minus I is equal to 1. So essentially we're saying, okay, starting I at 1, we we do R plus I, just 2. So now we're in the row 2. We check, we subtract. Okay, yeah. And then we check the column, which is C minus I, which is 1, 1 minus 1, which is 0. So now we're in 2, 0 in this spot. And we see that there is a conflict. There is a 1 right here that's conflicting with the queen we just placed diagonally. That, that covers that for loop. And it's a for loop since we go from 0 to C because we're checking like what's it called? We're going up until we reach the column that we're at, which is the queen that we just placed. We wouldn't want to check from I to let's say 8 because there's no point in doing that because you're just checking these empty spots that we don't care about. We haven't placed the queen yet, that spot yet. So there is no point in checking that. So that's why we're doing like from I to C with these for loops.
Two questions.
Yeah.
One, if it's equal to 0, does that mean that like it's just, like you place it on that spot, or does that mean there's already a queen there?
Sorry.
Sorry, if it equals to 1, sorry. If the if statement's equal to 1,
Like
does that mean you're
okay.
able to place the queen on that spot, or does that mean there's already a queen on that spot?
You mean like for these ones?
Yeah.
This is just checking. So if it equals to 1, right? That means that there is a queen in that spot. Because essentially like zeros are your empty spots and ones are basically the queens that you placed in the chessboard. So you know how in chess a queen can like move up, down, diagonally, and left and right. If there was a queen in this spot, right? This queen would can attack this one and like and get rid of it. We want a spot where the queens can't touch each other, either diagonally, vertically, or horizontally. So that's why when we do this if statement, we're basically so we're here, right? We subtract we subtract a row and a column, so subtract 1 and then 1. We're checking here if there is a queen, then that can't work because look diagonally they can attack each other, right? So we'd have to move this one queen right here, one lower, so that they can't conflict because a queen essentially can like move this way, or this way. So we want to move the queen one more down. Does that answer your question or no? My bad.
Yeah, it does. And
Yeah.
also, where do the for loops start and end? Like, are they nested for loops, or are they all 3 separate ones?
Oh, they're separate ones. Separate.
Okay.
They're separate because like, yeah, they're separate because this one.
So let me answer the question for you. So every for loop is for every test. So you can see in the comments, like before the first for loop, it's in the comment row test. So with the first for loop, you're checking if there's a queen in the same row. So that's the condition for. So if Q, R, and I in the same row, if there's a one means there's a queen placed there. That means that violates the rule. So you go to the next row. The second row is for the diagonal test. So because you're placing one queen after another, so if there's a queen in the diagonal, it should be on the left, not to your right, because you haven't placed any queen in the right yet. So the second for loop is for the up diagonal test. And again, inside the for loop, there's a if condition saying if Q R minus I and C minus I, that means go one row upper and go one column to the left. That means diagonal, right? So in the diagonal from your current row and column, if there's a queen, and how do you check it? Because if there is a queen placed there, the value is 1. So if the value is 1, that means if there's a queen there, the condition is validated. So you go to the next row. Again, and the third for loop, as you can see in the comment, is for diagonal tests, but downwards. And again, if there's any queen, it should be on the left side. So that's why like it's R plus I. That means you go one row after, and C minus I meaning you go one column to the left. So you check if there's any queen in the diagonal but downwards. And how to check if there's a queen? You check if they're on the from the current run column. If there's any one, you can detect any one there. If there's any one, that means there's a queen on that spot. And if you detect a one, you go to the next row because the condition is violated. And if you pass these three tests, these three for loops, that means like none of the tests could detect a queen in the same row, upperwards but diagonal and downwards diagonal. There's no queen. Then you place in that row and column, you place the value one, meaning you place a queen there in that row and column. If you could pass all the three tests.
The three tests are essentially like
So that's the condition of this question. So you can place a queen. You have to place eight queens on your chessboard. But when you place the queens, meaning you place the value one in the row and column in that row and column, there cannot be any other queen in the same row, in the same column, or in the diagonal. So like think about like imagine you putting one queen after another. So you putting a queen means you inputting the value one in that row and column. And after putting that one, you go to the next column. And when you go to the next column, it doesn't work out because there's already a queen in the same row, right? So you go to the next row, and after you go to the next row, you check that row. You check that row. If there's another queen in that row, there isn't, and you conduct the second test. If there's a queen in the diagonal but upwards, if there is, you go to the next row again because it validated your condition. If there isn't, you conduct the third test. You check like if there's another queen, like any other queen in the diagonal but downwards. If there isn't, you place the queen in that current run column you're checking on. But if there is a queen in the diagonal test, you just go to the next row again. Does that make sense?
Yeah, no, that actually makes perfect sense.
Yeah, like if you have any other if you have like more confusion, I'll share my own screen in the last later half and go over it again, okay? For now, like just continue with whatever because it's just 2 hours. Okay.
Okay,
yeah,
thank you.
yeah. Was your question about like keys, like when you end the for loop or
Yeah, because I don't know, usually I would just see like the curly brackets, whatever it is, on where it starts and ends, so it's just easy to look at. I'm just not used to
oh
seeing it without
oh
it.
yeah, yeah, it's really weird. It should be like kind of like this, but, or this is like the for loop right here. So, yeah. So if you pass all statements, if this for loop, you check if there's any previous um rows that, or any previous columns that have an I. If there's none, then that passes. If there's any diagonal, if there's any upper diagonal that like pass the test, then it's fine. Like here, this passes. If there's any one that's like lower diagonal, that's fine. It passes. If you pass all statements, then you can set that spot equal to one. So like you're placing your queen right there. So then from there, once you place your queen, so like in this right here, like right here, this passes, right? Because there is no queen right here that's attacking it. No up here that's attacking or attacking right here. So then we place our queen, and then we didn't have to place another queen in this row because you already know that queens can also attack vertically. So if you place a queen here, this can attack this one. So obviously you wouldn't check this. You wouldn't try placing any more queens in the spot. So then you'd move on to the next row, next column right here. This is our column. This is our column. And then from there we just keep on going again. So we just keep on going try to find a spot right here. Yeah, there. And we just keep on going up until like what's it called? If there's a point where we're checking like each row, right? To put a queen. Once we pass that boundary, so once we're like this is a chessboard. Once we're outside, when we're checking right here, if we can place a queen here, that's when you know that there is no solution for that. So then we backtrack backwards and continue from there. Continue from where we left off. So let's say like we have like um say we have like a queen right here, right? And we keep on checking and just like pretend that there's like no spots available for for this column queen. Then we go backwards. Then from starting from here, we check again, like move it down here. Doesn't work, then move down here. We just keep on going. If again this happens again, like we reach to the end, which is r equals 8, so we're out of bounds, then we backtrack again up in here. And from continuing where we left off of where the queen was, so like let's say the queen was right here, it was perfectly fine here. And if we have to backtrack, then okay, let's continue moving it down until we find a spot that works. Right here, right here, right here. And that's how the essentially the backtracking works. Up until we find the spot right here, we continue from continue the next column, and we just continue off from here, like right here. We keep moving to like right here, then like right here, and then once our column reaches out of bounds, right here, essentially right here. Once we placed our last queen, then you know that all right, this is a solution that we could print out. So we do right here the statement c equals 8. That's what essentially means that we found a solution. That's when we go to print, and we do the print solution, and then it takes us to backtrack again. So we go backwards because for this program, we're trying to find all solutions, all possible solutions for the 8 queens problem. So once we find a solution, we move our C back. So C right here, and then we just continue from where we left off, like queen moving and all that, like this like the backtrack um, method. And then if it's to a point where we found um, if we found like all the solutions, right? It's gonna be to a point where we run out of solutions, and it's to the point where we're gonna our C is at the very start, and our queen. Let me up a little bit. Our queen is at like the very last row, because there's only a finite number of solutions for this problem. So once our queen's at the last row and we can't find any more solutions, eventually we're gonna have to backtrack up to the very out of bounds, like right here, where our column is gonna be -1, and that's essentially when it's c is less than 0, we end the program. So that's essentially the stopping point of finding all the solutions. Up until we have no more solutions, and we have to backtrack out of bounds for the column. Does that make sense? No, I bet it's a bit rough.
And is the line right after if C is less than 0, the line right after that, is that just resetting the row, pretty much making them all equal to 0?
This one?
Yeah.
Oh yeah, for sure. Yeah, because you wouldn't want to leave like a zero, like a one queen there. Then if you like go back to that same column and there's already a queen there, it might conflict, something like that. Because then there'd be like two queens, the um same column, so that wouldn't work. Sure. You very quickly go over the 3-in-1 test for the eight queens. So, okay. So far is this okay? Is there any more like questions you have for this program or no? For the 2D array eight queens?
If I could just get a clear picture of what the print program looks like, the print function at the bottom, if that's
Mm,
possible.
yeah, I have this here that someone shared with me. This is what it looks like. Yeah. So you're like printing out like um all the whole board. So like you're like printing 0, 0, 0, 1, 0. You just keep on going like 0,
It's just a
1,
nested loop,
0.
and you're just printing out the board. That's it.
Yeah, just that's the you're
Okay.
like going by I's and J's. So like the rows and columns.
Okay.
Okay. Is there any other questions you have or no? Or is that it for the AQ problem? Because then we can just move on to the next topic you guys want to go over. Okay. 2, 3, go over.
For
Like
labels in C++, do they have to be on the same line, or can you like make a new line and still have it under the same label?
like you mean like the label be right here, the label be right here, and then you mean like have it right here,
Yeah, like does it have to be all in the same line, or can you make a label and then go to the next line and still have it be the same thing?
like right here.
Yeah.
Yeah, that works too. Because like
Okay.
you like, when you do like a go-to, you're essentially jumping from this line and then continue from there. So yeah, can one of you guys share me with the eight queens 1D go-to? Thank you. Okay, so you have Q equal to an array. One, three, four. So you have this row. You have your column equal to 0. You see equals 8 vector. Okay. Okay, so starting from here, P equals 0. QC is QC or Q at C is not equal to 8, so we don't go do a backtrack. We have a for loop until C. Uh, if Q of I, which is starting at 0, is equal to QC. Or the absolute value of Q at C minus Q at I equal to C minus I equal to invalid. Q at Q at Q at I is 0, 0 equals 0, valid. Value valid. Okay. So essentially how this array works, right, is that it's the same thing as the chessboard, just formatted differently. As in like when you have like numbers here in this what's it called, this array, like let's say you have 0 here, 2 here, and 5 here. You're saying that like that number specifically is where the queens are located at. So let's say you have um 0, 1, 2, right? Then the queens for column 0 is at 0, so this would be like this. Our queen for column say column column 1 would be at 2, so that would be right here. For here it's 5, so it'd be like somewhere around here. It's really formatted. It's formatted differently, but that's essentially how the array is supposed to work. Like it's supposed to work. So when we do this statement, wait, Louis, um, hey Louis, I have a question. Wouldn't you, after the next column, wait, so from here, our column would be at 0, right? So we're starting up here, and you initialize it to 0. Wouldn't you also increment the c as well? Since you're saying that you're placing your queen at 0 now. So then afterwards you'd want to move your column to here instead, right?
Wait, sorry, what was the question?
So like, see right here, this is your code, right? My bad, putting on the spot, but this is your code, right?
Yeah.
So you see right here that when c equals to 0, we're starting at in this column, right? We're at 0, right? Which is the first column of the chessboard, right?
Yeah.
When you set q at c, so q at c is 0, so at this index, you set it to 0, right? Meaning that you place your queen at that spot, right? At 0, 0. Wouldn't you, wouldn't you after that, like right here after this, wouldn't you do a C plus plus? Wouldn't you move your next column to here instead and not keep it at 0?
Um, I mean, I have this, I have it underneath there, C plus plus.
Oh yeah, you're right.
Yeah, right there.
Hey Louis, so I also have the code. Do you want to go look at mine, or because I feel like that's more confusing, right?
Oh no, wait. No, because I is less than 0, I is less than I is equal to C at that point. So yeah, you're right. It would still work. Never mind. Okay.
I know it'll work, but that's kind of confusing.
No, no, yeah, but like you're
Hmm.
basically saying that the the for loop statement is already gonna fail because you're saying that I is less than C. Since you're starting I at 0 and our C in the beginning is at 0, this this for loop is already gonna fail. So you move on to the next statement, which is plus plus C. So our C would now be 1. Good. Then you go on to the next column. Then you're moving your column here, and then from there, that's when you start the for loop. So if you put a column at 0, right? If you say we say this real quick. So let's say we move on to the next column. Our column equals to 1, and our q at c is equal to 0. Wait, yeah, 0. our QSC is not equal to 8 yet, so we continue. The for loop starting at I equals 0, and we want our I to be less than C, so our I is at 0 for now, and our C is at 1. We check Q of I is equal to Q of C. This part essentially means that if there's any this is the horizontal test where we check to see if there's any queens horizontally, because the number in these slots are the positions of the queens are where the queens are. This is like essentially the row inside. And the next statement is what checks if say C minus Q at I C of I this part is going to be our diagonal test for either or. This statement is going to check diagonally, as in like let's say like this. It would check for both cases by using absolute value if there is a diagonal conflict. The same premise as we do. Like if there's a backtrack, we go back and then increment this by keep on incrementing until we find a solution. Is there like a specific like question you guys had about this program?
For the next row label, how does it work in the 1D? Because there's not really any rows to go through.
For this one?
Yeah.
For this Q of I equals Q of C? Like the estimate or
I was just talking about like the next row line, just that one. That's it.
next
Like,
row?
what does that mean if QC equals 8, go to backtrack?
Okay, so like I said, right? So our C is gonna be like a column, right? Like where we're at, like right here, right here, right here, right here, right here, right here, right? The number inside that array, like right here, the spot, that number is gonna tell us which row we're at for that column, for our queen. So like if we had like a 3 right here, that means our in column 3, row 3 is where we have a queen there. It's like that's where our queen is. Because that's like our the number inside here is the row we're in, and the index of the array is the column we're in.
Oh, so QC is talking about the row where C is just talking about the column?
Yeah,
Okay.
that's essentially what it's saying. So once we reach 8, meaning that once from 7, like this is the last row we're in. Once it reaches to 8, that means that okay, so this spot is empty, 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 this spot is empty. And once we're outside of that, this is like the chessboard right here, like the column of the chessboard. If we reach out of bounds and we're like at 8, where we're not allowed to go, that's when we go backtrack again. And from here, you see it the QC here at this 3, right? meaning that our queen is right here. It's in the third column, third third row. That's what it is. So like, let's say this number, right, was say 6, right? 6, meaning that okay, this is row 0, this is row 1, this is row 2, this is row 3, this is row 4, 5, and 6. So we're here. But we're like right here in this spot. It's like a new way of like saying like using a Q 2D array, where instead of like the specific index equal to 1, meaning that there's a queen there, instead we use the index of Q as our column and the number inside of it as our row. It's like saying let's see. It's like saying like this. C is our column is our no Q of Q of C is our Q of C is our row and C is our column of like Q, or like the chessboard. Chessboard. That's how like the array works for this one. And you keep on incrementing it for the first case. If Q of I equals Q of C, you're checking if any of these numbers are equal to the row. Meaning that, so let's say like these numbers, right? But you're saying like this, right? If 3 was 3 and 4 was 3, that means column 3, row 3 has a queen. So 0, 1, 2, 3 has a queen. 4, 3, which is say 4 column 4, row 3, 0, 1, 2, 3. This is a conflict, no? Horizontally, this is a conflict. Since these two queens can attack each other, then that can't work. You're gonna have to move this queen down to 4, which is what this statement is saying right here. Q of I equals to Q of C. So you're checking every row, so like every number inside here, to make sure it doesn't equal to this number, to the current column we're on. That's how the statement works. This one as well. This one, absolute value of QC minus Q of I equals to C minus I. My bad. Wrong there. That just checks if the that just checks diagonally wise. Like diagonally, just checks if there's a conflict diagonally, basically. That makes sense or no? My bad. Like,
Yeah, I think I got it.
okay. Are there any other specific spots that you want me to go over for this program or no?
No, the rest pretty similar to 2D.
Okay. So, since this is your first exam for Waxman, the question's 1 out of 50, I think, or I think it was 1 out of 50 or 1 out of 60, 60, 160, or 150. Um, so 1 out of 50, you have 50 extra points to get a higher score. So you could answer questions on the exam that like are more easier for you guys, rather than answering like really difficult ones. Because you know how like the typical standard like exams are like 1 out of 100, like 100, right? You like that's the how much that's like the max score you can get. for Waxman's exams, they're the same thing, 100, but there's also 50 extra like points. It's like extra questions that are 50 points that you could answer instead to get the 100%. You guys get it or no?
Yeah, but I'm just a little confused. Like, let's say, for example, I know it's hard to do, but like, let's say you get over 100 points.
Yeah.
Would that be extra credit, or
No,
just would it would just be counted as 100? That's it.
yeah, 100. Because like
Okay.
so he's giving you more questions than needed so that you guys can freely choose what questions you want to answer. So like you like, during the exam, you might have like encounter a difficult problem, right? And you're like, oh, I don't know how to solve it. You can like you have some free like some leeway and move on to another question that you're more not knowledgeable on. So like it'd be so you'd like you just go for questions that you know first. It's supposed to help you guys out, um, get a better score on the exam.
Also, I was watching, I believe it was last semester's, like recording of this exact thing,
Yeah.
and they were saying something about like how he has like coding questions, obviously, but there's also like just like logical riddles that don't really have anything to do with coding. Is there? It could be anything like that on the exam.
Mm, he likes to include some riddles, but they're more like just like random throw-ins. Like they're not really meant for like coding, but they're just like more like fun questions to like answer if you can, if you can figure it out. It's just like they're to help you out. They're usually given as extra credit though.
So
I
here's
recall,
like out of 100 points, right? So out of 150 points, you're gonna have multiple questions. Right? Let's say one question says tells you to do the 2d8 queens. One question is 1d8 queens. One question is the eight numbers in a cross. One question is the race program. One question is the stable marriage. There could be like 3 to 4 riddles, right? But here's the thing, like you got 150 points, you need 100 points, but you could choose to answer every question, okay? Like you cannot like there's nothing like yeah, I answered this many questions, so maybe I cannot answer the rest of the questions or I answered 100 points worth of question already. So the rest of the questions maybe I cannot answer. No, you can answer this question. Even after you like answered 100 points worth of question, you can answer more. So let's say out of 150, you answered 100 points out of questions, but you're not confident. Out of even after answering 100 points worth of questions, you're not gonna get, let's say, 80 plus, right? So you can answer also the remaining extra questions. Let's say after answering 100 points worth of question, you can partially answer rest of the questions. Go for it because if you answer for those questions even partially, you'll get partial credits. And he's gonna let you keep those scores even after what the hell? Okay. Even after you answer 100 points worth of questions, okay?
yeah.
So like
So
go for it. Go for it. Answer every questions. Even if you like know partial answers, even then go for it.
yeah, because
Like
like
yeah, like let's say you already answer 100 points worth of questions, but you're not confident you can get like 80 plus. Go for the rest of the remaining questions. Try to answer, let's say you're not confident you can answer the full code for let's say win the race program, right? But you know like the first couple lines, write those down. Leave nothing behind, like write it. Like you if you just so here's the thing. He literally copies the projects he taught in the class. So I would tell you for 1D array or 2D array queen problem, try to memorize. This is not encouraged, but we're doing this for getting the grades, right? So try to memorize the test, the next column, next row, and inside those you do the row test, the diagonal test, up diagonal, down diagonal, down diagonal. So memorize those parts specifically for 1D and 2D Queen's problem. Um, For the 8 numbers in cross, which I'm gonna go over right now, try to memorize. It's not even worth memorizing. Just try to understand how to do the helper array, right? For what's the other question? Stable marriage. For the stable marriage, there's this one function called OK, which checks like if your current matching is like if it's working out. So try to memorize that function. If you cannot understand what's going on, try to memorize that part because from the past couple semesters, he's been only asking about that part. Like he's gonna ask you to fill in the blanks for the OK function for stable marriage. So try to like understand slash memorize that part. So that should cover more than half of your points. Does it make
Yeah.
sense? Okay,
Yeah.
now
Yeah. Just like,
yeah,
sorry.
question. Of course, question.
Sorry.
Question? You got any question?
No. I was just saying that like um I was just saying that yeah, what you said was right. You guys should try to like answer every question because you
Yes,
know
exactly.
because yeah, like you said, if you try to go for 100 points, then like okay, I'm done. I don't want to answer any more questions. Like
Yeah,
I
like
don't
it's
I don't
confusing because he gives you the option to answer, but he doesn't tell you like yeah you can answer those, but actually you can. He's
yeah
gonna he's gonna he's gonna like give you points for answering those questions. But it's like this perceived knowledge like yeah I already answered 100 points worth of question now maybe I cannot answer more. Even I thought even I thought that in the first, but you can answer more, like answer more questions, even after answering 100 points worth of questions.
yeah
Is he usually generous with like partial credit, or is it more like
Yes, yeah,
broad?
he is very
yeah
generous with his exams. Like even after like you basically know what's coming in the exam. Even after that, like people do not tend to do well. So he curves a lot. Like whatever your score is, so root over your score times 10 or 11. So it's like if you get like 70 something after curve, it's 80 something. If you get 80 something after curve, it turns into 90 something. So I don't know how much more generous you can get.
yeah the curve too. They also get really good for the exam.
Okay, so like yeah, that was the tip. Just memorize those tests, the row test, up diagonal, down diagonal for 1D and 2D array. Because those are the important parts for 8 numbers in a cross. Even that's pretty simple. Just go over the helper array function. For stable marriage, go over the OK function, which checks if the matching is stable or not. That's like more than half of your worth of questions. All right, Louis, you can continue. My bad.
Yeah, that's cool. But so we can go over this part. Uh, see out, see out. This is like an example question that you have. See out. Size. Okay, let's go over this. Okay. You guys want to tell me like answer these questions for me? See what size of B is for this question.
The size of the array, it would be, oh, someone already said it. 24.
24, yeah.
It's because it's like the rows times the columns times 4.
Yeah, but why times 4 though? Do you know why we times it by 4 or no?
Oh, because the size of sorry, it's the size of the integer inside the program, which is 4 bytes, and since
Yeah,
it's an integer array, that's why we multiply by 4.
yeah, that's good. And then size of b plus 0.
It should be
That would be the
40,
size of the pointer.
48, right, Lewis?
Sorry.
It should be 48, right, Lewis?
All right.
Because 3 times 4 is 12. 12 times 4 is 48, right?
Wait.
Every box is 4 bytes. Every element is 4 bytes.
No, wait. No, wait. No, because you have each box is 4 bytes, no?
Mm-hmm.
So 4 plus 4 plus 4 plus 4 plus 4. That would be
Oh yeah, my
24.
bad.
Yeah, that's good. That's cool. Yeah, 24.
It's 24, it's 24. My bad.
That's cool. Then b plus 0. Like, what were you saying? My bad.
Oh, I was gonna say like b plus 0 is 8 because in 64-bit programs, the size of a pointer, which is what it's asking for in this case, is 8 bytes.
But for this one, right?
Yes, b plus 0. The one with the asterisk is different because it's asking for like the sizes of rows 1.
No, but isn't this one talking about like this specific part? B plus 0. This
Mhm.
part.
It's pointing to the
Yeah,
first
but
row.
it's not like a pointer though. Isn't it just like only this? 4 plus 4 is just 8. Because it's still giving like the address, no, like the size of this array. Is it not? This is the one where like the pointer matters. This is where dereferencing. Because b plus 0, you're saying it's like this spot. It's this like row. So the size of this row are the two integers. So 4 plus 4 is 8. No. You get it or no? But
Yeah, I get it. Yeah.
yeah, this part it's sorry. This part, yeah. I mean, yeah. What you said like earlier, it works, but for this part though, because sure you're pointing at this, right? At this what's it called, address, right? Of this array, but you're dereferencing it, meaning that you're making it to a pointer. So the size the the size of a pointer is 8 bytes. So it'd be 8 for this case. Does that make sense? You guys have any questions about that?
No, she was sitting on a
Essentially
folding chair and I
it's
don't want
just
to fall.
the
Yeah. So.
size of
She was horrible.
the
That wasn't it.
address
Um,
instead of
oh
the
my God, she's so cute. I went in there
it's the size of the
and
address instead of
we were
the
playing
array.
numbers
These
and
two
I
were
yeah, and then me had his ring on. So it was like, show you the deck. He's like, yeah, sure. I said,
size of
you were
array.
watching, right? And she was like, yeah. You see her brother Calvin.
Oh wait,
Hola, so you gotta come in here.
Hey,
but
MD,
yeah,
can you mute your mic?
yeah,
Thank you.
but yeah, like right here, these two are asking the size of an array because b points to the whole entire array, while b plus 1, I mean b plus 0 points to this array. This like the first stack of the array, like right here, compared to the other one. So this part, sure, this part is pointing to the array of the same array, right? But you're dereferencing it right here with the star, meaning that instead of giving me the array, give me the address of the array.
Getting the
And get
values.
sorry?
Oh, you're getting the values when you use the dereference.
No, you're getting the pointer of the array. Like you're getting the address, which is essentially like pointing to the address.
Oh, okay. Got it.
So yeah, pointer, which is like a pointer. So a pointer, I mean, yeah, it's like ref.
Professor?
Yeah.
I mean, I put it into like VS Code and everything just to like see exactly what comes up. And yeah, it says that b plus 0 points to 8. I mean, I did my own 2 by 3, but still it shows b plus 0 is a pointer, and dereference b plus 0 gives you the like value of the integers, like basically value of the row.
Equals 0 gives you the
It's I was wondering because when you do arithmetic on like let's say on the array or like on a variable, it turns into a pointer. So I was just wondering. I always thought that when it said size of like p plus 0, it was just referring to like just the size of a pointer. But okay.
also then it is a pointer, or is it not?
I believe it is a pointer because I remember when Waxman mentioned how when you perform arithmetic on it, it would turn into a pointer, and like the size of a pointer in a 64-bit program is 8.
Okay. Then this part returns the value. This part of referencing b plus 0.
Yeah, I just I sent my example in the chat.
Mm. I'm just a bit confused on like how we got 12 though for the third one.
Because I have a 2 by 3 array. You have a 3 by 2. It just
Oh, okay,
flips.
okay. So so what you're saying is that this returns the pointer
Yeah, second returns a
there.
pointer, and third returns the value of whatever row you're referencing to.
Right.
So like this example, right?
Yeah, pretty much.
Exactly.
Okay. Yeah. So is okay right for now, guys? You guys get it? Yeah,
I
yeah.
mean, yeah,
Oh yeah,
I'm
definitely, definitely.
Okay, hold on. Then we have so when you say C out, C out, C out, C out. Okay. So we have these, right? What would the um first line turn out? Knowing that um,
Well,
this
it
is
would
the
see out that address. Or
yeah,
yeah.
yeah, it's yeah, that's right. What about this?
For b plus 1, that would be that would see out that would oh my gosh, that would output the address of the second row of the array.
Second row of the array, right? So you would have to um
Add 8
yeah,
bytes to like
add
the memory.
yeah, add it to the I'll just do it real quickly. Maybe start by let me start again.
Louis, you good?
Yeah, my bad. I'm gonna my program's kind of my bad. Go just the address was that's the address. You said you want to add 8, right? So 1, 2, F, F, 6, 8. Since it was asking us to do B plus 1, yeah, B plus 1, this would be our B plus 1 at this spot. So you want to move total total of total of 8 bytes at 8 to 8 bytes this time. We do 1 times plus 8, 8 times 6, and our hexadecimal would be 8. So we just add 8. This would be 16. Then this would be 1 and 0, be 7. And the rest would just stay the same. 0, 0, 1. The reason why is because we didn't put like 16. It's because of hexadecimal. Numbers go from 0 to 15. So starting at 9, right? The values would stay the same. So base 10 and base 16 afterwards, let's say 10 right here, which would have 2 digits, or hexadecimal would be A. Then from there would be 11, which would be B. 12 would be C. 13 would be D. 14 B. And then 15 would be up to there. That's when we stop. So let's say that let's say that it was instead like it was 4, right? We had to add 4. Instead, our hexadecimal would be
Or you'd
8.
put C at the very end.
Yeah, 'cause 8 plus 4 is just 12. And then according to the chart, it would just be C. There would be no 1 here, so it would just be 6. So instead of like having like a 1 through 9 range, like a 0 through 9 range, you have a 0 to 16 range, where instead of like having 2 digits, you have letters instead, like A, B, C, D, E, F, G.
Wait, Lewis, I have one question.
Yeah.
So like by the F, right? I would, is that like a 16 or an 18? Because I thought
No,
F
no,
would be
yeah,
15.
yeah, 15. I agree with you.
Okay.
I have a question. When we're adding the bytes, do we have to convert it first before we add into the address to
Yeah,
hexadecimal?
yeah.
Okay.
Let me, just, let's keep that. So like, say, let's say you have, remember we had C out, the n%, the n plus 1 plus 1. What would this print out exactly?
It would print out like the address like outside of the array, like after the entire.
Yeah, yeah. This is a B address. This is like the address itself. It's not combined into one like this. These two are separate. The address of B and the B plus 1. These two are separated. So, like you said, yeah, it's the print out the array outside of the array. Is like this would be our array, right? Four.
So then in that case, it would be like adding 24 bytes to.
Yeah, exactly. It'd be 24 bytes outside because this is starting point is our B. It's also B plus 0 and B plus 1 right here, and then B plus 2 is right here. So when we say the address of B plus 1, we're saying that so after the array, we jump outside of it to the next one. So B plus 1, like that. So you're jumping outside of the array. So the total amount of storage size, size of the array is what you're adding to the base address. So this is our base address. So, and since we have 6 slots, each with size of 4 bit integers, 4 byte integers, you would add to the address 24. But so it wouldn't be exactly 24. You first have to convert 24 to the decimal. This is to the base of 10. Say So we have this spot, no, wait, this spot times 16 to the 1 plus this slot times 16 to the 0. So we need two hexadecimal that add up to 24. We could just have a 1 right here, right? That would give us 16. This multiple is 16. We need 8 left from this, so this spot would be 8. Do you guys get how I got this so far or no? Yeah, I went over it quick, but
Yeah.
okay. So 24 would be our number base 10. We want it to be hexadecimal, which is base 16. So our this would be just this would be 18 in hexadecimal form, like that. So when we go up here, instead we're doing plus 18 instead of 24 because we first convert it into hexadecimal. So 8 plus 8, it's out of hexadecimal, so this would be 1 and 0. 6 plus 2, that's be 8. Then it's going to be there. No, the key just stay the same. Let's say this was, um, 4, right? These two would be 0, same thing. 6 plus 5 would be 11, right? So this would be B instead. So it would be 0, 0, 12, FF, B0. You guys understand so far? Any questions at all? Any questions at all?
Oh, yeah, I just briefly left. I was wondering how come we're adding 48?
Oh, no. I just replaced the number with something
Oh,
else.
okay,
Like,
okay, okay,
to
okay.
give you like a different look. Since 8 plus 8 is 16, but it's out of it, so it just be 0. And
Oh, yeah,
you
yeah.
carry the 1. 6 plus 1 plus 4 is 11. Yeah, 11. And in terms of 11, in terms of hexadecimal, that'd be a B. So replace it with a B. But
And yeah, and since it's 11, there's no carry, so the next one just remains as
yeah,
F. Yeah.
since we're not out of 6, out of 15. So are you guys okay with this? Like the conversion, like knowing that B plus 1 jump outside. Essentially, you're saying that the address of B plus the whole size of the array would give you size of the array, but you first have to convert the size of the array into hexadecimal. So you find that, and you get 18, and then you have to add that number to the address. Is that clear with you guys? You guys understand that so far?
It makes sense. It's just with something like B plus 1, for example, are you just when you add the first row and you take its bytes, do you convert it to to what's called do you convert it to hexadecimal or is it already in hexadecimal
You mean like this or
for just B plus 1? No ampersand.
plus 1? Um, I mean, either way, you're still converting it hexadecimal, no? Because let's say, yeah, you would still convert it because let's say you have B plus 1, right? You're jumping by 8 bytes now, or 4, 8, up to this point, right? Right? So you have 8 bytes, hexadecimal, it's essentially still the same thing. Like, let's say you have 60 to the 1 plus 60 to the 0. You don't need 60. You don't need a whole 16. You can just put this with 0. All that's left is just have an 8 in there. And that's the same thing. Just 8. That's it. So you're just like adding the same number, yeah, basically.
Okay, I got that.
It's just like, yeah, that kind of deal. You'd add 8. That'd still be like 7, pretty sure. Just like it's just like that this specific case says that jump outside of the array and give that address instead. Do you have any more questions, guys? Or anything else?
Pretty clear.
Okay. Is there anything else quickly before the time runs out? Is there anything like anything small right now that we can just go over quickly? Or type in chat if you guys want to. So I should just close it off right here, but like let me just say that yeah, like what MD said, just try to answer all the questions as best as you can. The the riddle the like mind riddle ones that you mentioned before, those are just like more of a fun questions that you can answer. I'm not sure how many there is exactly, or yeah, able manage.
I believe there's like one riddle where they talk about like four men in like in black and white hats.
No, yeah, well, the riddles vary from
Oh
exam
yeah,
to
it's
exam,
definitely.
but yeah, just like fun riddles like that he just throws in just for
Do
just
you
for
have a quick riddle just so we can like see like roughly what it looks like?
Yeah.
I'm just a little curious.
only one I recall is like uh, I don't have an exact riddle. There should be like the old review sessions I think should have some if I remember, but I just recall one where like there was three men. They worked like different jobs, and then by the end of the riddle, he asked, "What job is each person doing? Like what job? What's their occupation basically?" That's what one of the riddles were. Something like it's not really CS related. They're just like random riddles.
Okay, I was a little curious.
Yeah, they're usually for like they're usually just
Like for me, I just did the other questions, like every other question except riddles, because I didn't want to like waste my time after some riddles. I just did all the other questions, and I got like 100. So like, you know,
yeah. I
not
see
even
just most
like
of the
first do not waste your time after the riddles. First try to do the actual questions, and then like after those questions, if you cannot answer anything else, then like you're free to like waste some time after some riddles. That would be like my opinion or advice. First try to like do the actual questions. If you cannot, then you can go for the riddles. Because at first, if you look at the riddles, it'll just waste your time. Anything else you wanna go over?
yeah
Last
yeah.
one.
You want to go over the
Stable marriage.
yeah.
Do you wanna do it or do you want me to do it?
Well, you can do it. Yeah, sure. I have the code right here. If you want me to screenshot.
Okay.
Right here. essentially, yeah, this is like the chart for the male preference and the woman preference. There's gonna be like these check statements for the OK function, where you want to see if 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 two couples, if either if one of them prefer each other, if both of them prefer, if both, let me start out. You have it or no? Let me send it to you, please.
Louis, you were slightly cutting off.
Oh, sorry, but
Yeah, I can hear you now.
All right, Lewis. If you want, I could do it.
Okay.
Okay.
I'll send it in chat real
Uh,
quick.
can I switch?
Send it in chat.
Screen share.
The exam is also gonna be like a lot of like fill in the blanks, like type questions.
I see.
Yeah,
Do you see the screen?
yeah.
Yeah, I see the screen.
Okay, notebook.
Slow lovely.
All right. Is it clear? The whole thing?
Yes.
Okay. So the question. Okay, I'm gonna try to be very quick. Okay, you have a couple of minutes. So the question is, yes, it's like a Tinder, but whatever. So first, you got two arrays. This is male preference. This is women preference. For every male, you rate the women. For every row is for male one, and every column is women zero, women one, women two, and this is men zero. So for men zero, okay, man zero, he rates the woman zero, zero, women one, two, women two, one, and the rating goes as the lowest number is the highest ranking. The highest number is the lowest ranking. So let's say zero is the best, one is mid, two is I don't know what's the word, but yeah, you get it. So that's a rating. And for women, women's preference, same thing. So women one, they rate sorry, women's zero, they rate something, second man something, third man something. Woman one rates the first man something, second man something, the third man something, and it goes on. So till this, you have the rating chart. After that, so this is all part of the Boolean okay. I'll tell you to memorize this part if you do not get it, but I'll try my best so that you can get something out of it. All right. So the first part is the rating chart, and then is the for loop. The loop is for checking the current matching. So you start with you start the counter I with zero, and when I is less than C, you keep checking the condition over here. So when you use the Boolean okay function, you're gonna put Q current man and the number. So this is your you'll be like some number, and you're gonna keep checking until that number. So you have three conditions.
Yeah, so C in this case would be like, C in this case would be the new man slash woman we're looking at, and
Okay.
and once we
Yeah.
iterate
So
the
the
I, we're like looking through the current like matches right now. So like,
mm-hmm.
so like in the if statement,
So
right? Oh, yeah,
yeah.
no, that keep going.
Mhm.
Not bad.
You can go on. It's okay.
Okay, yeah, yeah. So when we check in the if statement when MP I at QC is less than MPI at QI. This means that for I, for MP for the one on the left, we're checking if the current man we're looking at, and the new woman that we're looking at have a better match than the current man we're looking at and the current wife we're looking at. So if that's the case, if the man prefers the new woman, then okay, that's true for one statement. Now we check the next one, the and. And if the for the woman preferences, if the new woman prefers the new man and prefers the new man rather than their current their current man, then it contradicts that the marriage is stable because the both couples, one of them prefers each other. So if that was the case, then it would be an unstable marriage, and that wouldn't be like a good like matchup. So we'd rather have every person be with their best partner, even if they don't like it. No, C is the new man is the new man slash woman that we bring. C would be the current man, I mean the new man, and QC would be the new woman. I would be the current man, since we're gonna loop through the whole through yeah. So the reason why it's like less than rather than greater than is because remember, the less the number for the matchups, the better. If they're a higher number, so you can see it's 0, 2, and 1 for male preference. 0 is the best number, is the best like rating, while 2 is the least. So that's how it go. So for these cases, you want a lower number rather than a higher number, which is why we do the less. Yeah, yeah. Q of I is also the current woman as well that we're looking at. So that's how it go. So we check
Yeah,
those.
like that's pretty much
Yeah,
yeah, that's pretty much how it is. Like first you check like if man I if already he has the current woman. So
yeah,
that violates the our condition. Then or the man I here prefers the current woman more than because 0 is the perfect score. So if his preference for current woman is less than his woman right now, then and that woman, current woman, if he likes the man I more than her current man, that's why the less. So if the current woman likes that man I over here more than the actual her current, then it contradicts it. So they're both gonna leave their current partner for the other one. So it does not work. Similar thing for this one too, this part. So in this part it says the current man, if he likes the assigned woman more than his actual current woman, and the current woman, no, the and that woman, if he likes the current man more than the assigned man, then even this doesn't work out. So return false because if any of these are true, they do not work out. So return false. If you go past all these conditions, that means current matching is stable. So we return true. If that it Even if it doesn't, I will just tell you to memorize this part for the grades
yeah.
because you know
Because there are a
this
lot
session
of
is
like
for getting better grades.
because there's a lot of like more. It's more fill in the blank rather than writing the whole program. That's what a lot of the
Mm-hmm.
questions are about.
He didn't ask you for the whole program. He's gonna give you this whole part, right? He's gonna give you the ratings, maybe, maybe not, but what he's gonna do is he's gonna leave this part blank, like this part over here blank, and he's gonna tell you to fill it up. That's literally it. He's not even gonna give you the whole code. Like there's a 95% possibility. He's just gonna give you this whole thing function. He's gonna leave this part blank. You just have to write down conditions over here. So if you just memorize the condition, you get a lot of points. But if you wanna like, actually wanna understand what's going on, we can always come back to learning commons. Because
Yeah.
this whole session is for getting good grades. Okay? Shit, this is being recorded. I should not say this, but you know, it is what it is. I should not say this right now.
Yeah.
But yeah, like it is what it is. Yeah, like we want the grades. Yeah, like we're out of time, but even this is pretty simple. This is the 8 numbers in a cross. All you need to know is the helper array. So he's gonna give you like 8 boxes. This is labeled as in like 0, 1, 2, 3, 4 over here. But in the exam, he's gonna shuffle these numbers. So these box could be 3, this box could be 7, this box could be 2. Like he's gonna shuffle these numbers, and then he's gonna tell you to like write the helper array function for the given box. It's pretty simple. So for box 0, you check the adjacent boxes. So for each box, like let's say this box, you check the adjacent boxes, but only to the left. So for box 4, the adjacent. So box 1, 2, 3, 4. So 0, 1, 2, 0, 1, 2. Okay, only to the left. So 0, 1, 2, 0, 1, 3, and that's it. And we end every column with -1 so that our for loop can stop. So you only look at the boxes to the left, upper left. So let's say for box 10, no, for box 3 is gonna be 0, 1, 2, -1. We're not gonna do 4 and 6 because hypothetically we did not fill that up yet. It's like the 8 queens problem. You keep filling. So when you look at box 3, we do not look at these 2 boxes over here because hypothetically we did not fill them up yet. So you only look at the box adjacent to the left corner, upper left. For 6, that if it's box this, it's gonna be 2, 3, 4, -1. Here, 2, 3, 4, -1. For box 7, it's 3, 4, 5, 6, -1, -1. So it's pretty simple. All this is gonna do in the exam is numbers, and you're just gonna write the helper array accordingly. Does it make sense?
Yeah.
Okay. Any other question? Last minute questions? Because I think we already give all the tips. Yeah, like that's pretty much it. If I want to go over briefly, again, go over the 8 queens 1D problem. Okay, go over the 8 queens 1D problem. The important part is this part over here. Try to memorize the row test, the up diagonal test. So this is one way you could do it. This is another way you could do it. Different methods. So here you're doing the row test and diagonal test separately with 2 for loops. But here, inside one for loop, you're doing 2 tests simultaneously. So here, the first condition, row test, the second condition for the diagonal test. So if any of these conditions are true, you go to the next row. So this is the important part for 1D array. For 2D array, again, the same test, row test and diagonal test. That's the only difference between 1D array. Everything else is pretty much the same thing. So just memorize the row test and diagonal test for 1D and 2D array. Everything else pretty much same. Inversion across, again simple, just try to understand what the helper array is. Stable marriage, the OK function. Inside the OK function, just try to memorize the conditions. For what condition is gonna return false, or else it returns true. The conditions over here. And after that, there was another topic Luis went over. It was the reference. So reference, address of the array, size of the array, those topics. And yeah, like, that's pretty much it. And the riddles. But again, as I said, like first try to and after you're done with the actual questions, then you could look at the riddles and try to answer those. And that's like my personal opinion and advice. And yeah, like that's it. If there's not any last minute questions, I wish you best of luck for your test.
Yeah. Just like try to answer as much as you can.
And yeah, yeah.
Even if like you don't understand, you don't fully know the answer, try your best to do it because he might get partial credit. His exam is 1 out of 1 is 160 points. So take advantage of that. Don't just answer like 100 points worth of questions. Try to answer all of them to get the max you can get. And yeah.
Yeah, and before you leave, please fill out the feedback form so that we can do better.